Right, we're going to look at the cardiovascular and respiratory systems in Chapter 2 of the NSCA book. The cardiovascular system being the heart and the blood vessels, and the respiratory system, the lungs. And so if we look at the heart first, we see that there's two upper chambers, the left atrium and the right atrium, and the two lower, more muscular chambers, the left ventricle and the right ventricle. And your heart sits in your chest, with the left atrium being on the left side of your body and the right atrium on the right side of your body. So it sits in your chest the same way we would say left and right side of our bodies. Blood returns to the right atrium carrying waste products from the rest of your body, carrying carbon dioxide, through the superior vena cava, and that brings blood from your upper extremities and your head, and the inferior vena cava, which brings blood from your trunk and the lower extremities. And this blood then empties into the right atrium. And when the right atrium contracts, the tricuspid valve opens up, which allows blood to drain from the right atrium into the right ventricle. When the right ventricle contracts, the tricuspid valve closes to prevent the blood from leaking back up into the right atrium. So when the right ventricle contracts, blood then is transported to the lungs where it exchanges carbon dioxide for oxygen. And now the oxygenated blood returns to the heart through the pulmonary veins and to the left atrium. Then the left atrium contracts and the mitral valve opens up, so the blood can then be delivered to the left ventricle. And the left ventricle is the most muscular, largest chamber of the heart. And the reason why that is it has the responsibility of contracting and sending blood out into the aorta, where branches then go to the rest of the body. So that's why it's such a muscular chamber. Now, the heart has its own blood supply, which are called the coronary arteries. And those branch off the aorta, and they distribute blood flow to all areas of the heart. Your heart does not get nourishment as the blood travels from the right atrium to the right ventricle. It does not get its nourishment in that way. It's through the coronary arteries that it brings its nutrition. And the coronary arteries are the vessels. When you hear of somebody having a heart attack or heart disease, it's to the coronary arteries where there's some blockage that prevents the delivery of blood to an area of the heart or cells of the heart. And if they don't get an adequate supply of oxygen, then those cells are damaged in the process of a heart attack. So cardiac muscle, we've talked about skeletal muscle. Cardiac muscle is a little different. Skeletal muscle was under voluntary control, where cardiac muscle is involuntary. Skeletal muscle was multinucleated. Cardiac muscle is mononucleated. And the contractile elements are held together with what are called intercalated discs that hold them together. They have still some striation with the arrangement of the myofilaments, and they are cardiac muscle is fatigue resistant, and we call it the myocardium. Now, skeletal muscle, we had an axon that innervated, and the motor unit would innervate muscle fibers to cause the muscle to contract. And cardiac muscle is different. It has its own electrical system. And it starts out in the upper right-hand chamber, the upper right atrium. It has a specialized group of cells called the SA node, the sinoatrial node or the sinus node. And the SA node generates impulses. Then they spread through the right atrium and the left atrium in a wave-like fashion. And they stimulate the atria to contract. And when they contract, the blood flows down into the ventricles. Now, once the impulses spread out from the SA node, they encounter what's called the AV node, which is that Still, you see it in the lower part of the right atrium there. And that has a slight delay in the impulse. And that allows a greater time for ventricular filling, for the blood to flow from the atria to the ventricles. There is then at the single strand you can see running from the AV node, which is called the bundle of His, which then divides into the left bundle branch and the right bundle branch, and then those subdivide into what are called Purkinje fibers. And those deliver electrical impulses through the ventricle. And we can map the electrical activity of the heart. And when the heart contracts, electrical impulses are transmitted through the heart, but they are also transmitted through the body tissue and fluids, and then also to the skin. So if electrodes are placed on the chest, it can detect the electrical activity and then show this EKG, which is a depiction of the electrical activity of the heart. And each phase of the EKG is a different stage in the contraction of the heart. The P wave, it's much smaller, and that's reflective of the atria contracting. And it's smaller because atria are smaller muscle. There's not as much tissue. And then the larger QRS complex is the electrical activity being transmitted through the ventricles. And so you can see it's a much larger complex, and that's reflective of the greater amount of muscle in the ventricles. And then the T wave is when the heart repolarizes so that another impulse can trigger the heart to contract. So this is, you'll just have one cycle following another cycle as the heart contracts. And the EKG can be very informative of problems in the heart, areas that are conducting impulses, and so we can do some diagnostics off the EKG.